Okay, so we said that we're going to need to find the data, but before we do that, we're going to uh, talk about what we talked about before in terms of that array-based formula. So he says after you've gotten the data from the web page and you figure out where the figure is that you want, that number, you're going to want to store that information somewhere, and you're going to usually use a separate worksheet for that. So he says let's create another worksheet called summary or synthesis or all products. So here's the data he says he puts on his sheet. So I added another sheet called summary to mine here. So he doesn't explain exactly everything, but he says the first few columns are reserved for the rankings that he's obtained by the web queries. In other words, we got rankings, and we got the time, and then this is the actual number, and these are some other numbers. He says he also stores the date and time the query is finished executing in column A. So here. That time data provides my basis for longitudinal summaries. So if we look up longitudinal study in Wikipedia, it says longitudinal study is a correlational research study, you don't have to worry about that, that involves repeated observations of the same variables over a long period of time. And basically, we call that a time series. In other words, we're looking at data over time. So in this case, we're looking at his ranking at Amazon over time. Right? We want to see what's happening at one point in time and the next point in time and so on. So that's called a longitudinal study, but I'll call it a time series. That time data provides my basis for a longitudinal summary as a baseline for the forecasting analysis that he discusses later. Now he says, okay, well, we get the sales ranking, but he says that's not really what he wants. He wants money. He wants to know how many sales he's made. He says it's the sales themselves that you're ultimately seeking, even though there are other things that might be interesting, but it's really the sales that you want. So how do you get the sales? So how's he going to estimate sales from ranking? So, okay, this is a little interesting, and maybe you're going to have to do something yourself. So this is similar yourself. So this is just an example of how you might think about it, but you can do it basically the way you want. You can come up with your own idea. It's okay. And I'm sure you'll have some ways that you would take the data that's on a web page and then estimate some other, maybe estimate some other. So anyway, let's see what I'm talking about. Let's see what he does in this example. So how do you translate sales rankings into a count of sales? So we have the ranking, but we don't know how to get sales out of that. I started by tracking sales rankings on Amazon for about a week and noticed some points of interest. So he spent some time looking at what's happening on Amazon as the rankings change, telling a sale from no sale. A jump from a lower ranking to a higher ranking probably means the sale of at least one item. Remember, lower ranking means a larger number, and higher ranking means a smaller number, right? The best ranking would be number 1, which is the smallest number. If the item has no sales during a given period, its ranking declines. Okay, so he says if an item has no sales during a given period, its ranking declines. Why is that? Because other items do sell and so they move up, so that means that your item will have moved down because it didn't have any sales compared to others. So, how do you rank sales? You can't do it strictly on the number sold. A book, for example, here's another concept that he's thinking about. He says a book, for example, might have sold 200 copies over a 2-year period, but another book, so here's one book, sold 200 copies over a 2-year period. So 200 copies in 2 years. Another book sold only 100 copies, but it was just published last week. So which book is doing better? Obviously the one that sold 100 copies in just since last week is probably much better than the first one. The second book is clearly performing better than the first. So in other words, you have to consider the time under which it sold the books, not just how many it sold, but how long it took to sell them. So you have to combine time elapsed somehow with the number sold. Amazon doesn't say, but my guess would be that rankings are based in part on the ratio of sales to days elapsed since publications. In other words, sales per day. Well, that makes sense, right? Probably something like sales per day is included in the way that Amazon ranks. So we don't know how Amazon ranks, this book versus that book. We don't see it. We can't find out. We can't know for sure. But he's guessing that they're including sales per day. Improved rankings without sales. He says sometimes even though there's no sale, your rankings might improve. There are periods when an item's ranking improves very gradually over a period of hours. So this is something he observed by looking at rankings. He said he spent like a week checking out rankings in general, and looking at how they change. Okay. There's no reason to believe that an improvement from a ranking of, say, this to this indicates a sale. More likely, it is a result of another day passing and the rankings recalculating accordingly. So just because, so if you went from here to here, he says that even though your ranking improved, doesn't necessarily mean there was a sale. It could be that just the day increased and other books didn't did worse or something like that, and so it doesn't really mean that you had a sale. That means that before you conclude that a sale took place, you need a minimum criteria. So he's going to make up a minimum criteria. The criteria should be a rate, not a constant number. So he's saying, don't just say it has to increase by 10 or 20 or 30. Say it has to increase by 10% or 5% or something like that. The ranking has to increase by that amount. If a book jumps from a ranking of that to that, so that was an increase of 100, or actually I guess it's a decrease of 100, it's considerably different than if a book starts at here and goes to here. So 100 from here to here is not the same as 100 from here to here. So he says you should do a percentage instead. I decided to conclude that a sale had taken place. Remember, he's trying to guess whether a sale has taken place if an increase in the rankings equaled or exceeded 10% of the prior ranking. So he's going to use the 10% number. If the ranking increases by 10%, he's going to say a sale took place. So if a book was here at 3 p.m. and then here at 4 p.m., then how much percentage increase was it? It was 15 minus 13 over 15, 13% increase. So he would therefore, in that case, consider that a sale took place. Okay, so you can see that he's just guessing at this, and you might have to do something similar if you're working with some other data. You might have to sort of guess also. That's okay. But you should at least explain why you guessed in a certain way, so that the reader or the person who you're presenting this to will understand your logic. and that also you'll remember your own logic. Structuring the formula. So how do you do that? How do you implement this? Suppose that I have two rankings for a given product, one taken at 3 in cell C18 and another taken at 4 in cell C19. Remember, his spreadsheet looks like this. So here's a ranking C18 and C19, right? And so what do we want to see? We want to see what the difference was, but we want the percentage difference. If I want to test whether a sale took place between these two times, I can use this formula. And I'll put it in L19. Where's L19? L19. So remember, we were looking at, well, this is a little different actually. I think we were looking at J and K before, but this is in L. Okay, so here and here, so we check from from C18 to C19, how much change was there? Here we can see there was about 670 or 660 ranking change here. So then we just want to consider what percentage increase that was. So what we're going to put in this cell here is the following formula. Equals, if C18 minus C19, so that's a change from 3 p.m. to 4 p.m., divided by C18, so that's the percentage change, is greater than 10%. So if it's greater than 10%, remember the way the if formula works. Here's if from here to here, and here's 1 comma, and here's a second comma. So the criteria, the test criteria is here. So we're saying if this is greater than 10%, then we're going to put a 1 in our cell. In which cell? In this cell, we'll put a 1. Or if it's not greater than 10%, so that's this criteria starts here. We're going, I'm sorry, not criteria, this condition. Then we're going to put a 0. Okay, so he says the formula returns a 1 if the difference between the two rankings is positive and exceeds 10% of the earlier ranking. The formula returns a 0 otherwise. After the formula is established on the worksheet, I use the same VBA code that re-executes the query to copy the formula to the next available row. Okay, we don't know what that's going to do, but I guess what he's saying is next time we get more data, right? This is going to be running every hour, so we're going to get more data, and he's going to automatically copy this formula that we just saw into the next row and the next row and the next row and so on. Okay, so make sure this is clear. It should be clear. Just a simple if statement. Okay, next we're going to do this. I'd also like to watch two other statistics that don't depend. These are total sales per book, how many sales we've had per book, and minimum sales ranking attained by each book since I started tracking the ranking. So remember, minimum ranking means that's the best ranking, right? That is the highest ranking. Okay, so he's going to use these two. So we'll come back to that next.